This is the solutions for the mock exam for trig. We have a newly discovered pyramids arranged in a triangle. They kindly named them names that start with A, B, and C. A surveying team was lowered from a helicopter to the top of Andal to take measurements of the area. Andal is 40 meters high. The angle of elevation from the top of Andal to the top of Batsu is 3 degrees. So looking up at Batsu, it's 3 degrees. Angle of elevation. And the horizontal distance from A to B is 600 meters. Okay. So they have a very nicely drawn diagram here. 600 meters from the base of one pyramid to another. Andal is 40 meters high. And to look up at the top of Batsu, they look with an angle of elevation of 3 degrees. Okay, so let's find the height of Batsu. This is very similar to our investigation where we figured out the height of the school building. Okay, so basically we need to figure out this red height right here, which is pretty easy. We could just use regular trigonometry of right triangles. So we have a triangle here. It's 600, 3 degrees also here, we know, and we want to know this. So we could figure that out with the trig relationship that relates two sides of a triangle with the angle. And that, of course, is tangent, because we have the opposite and the adjacent that we want to know or that we already know. So we're going to write tangent of theta equals opposite over adjacent. So the tangent of 3 degrees is equal to the unknown, which we'll call x, divided by the adjacent, which is 600. And then we can find on the calculator the tangent of 3 degrees, and it'll give us 0.0524. And we'll multiply that times 600 to get x. So we'll have 600 times 0.0524. How did we get that? We multiplied both sides by 600. And 600 times 0.0524 is 31.4. Oops. And that would be this part of the height, but that's not all the height, right? We also need to consider this height here, which would be 40. So it would be 40 plus 31.4, which would be 71.4. Okay. Then we go to page 3. It says that Kartos, which is the third pyramid, is found to be 92 meters high, and the angle of elevation from the top of Andal to the top of Kartos is 4 degrees. Draw a similar diagram to the one in part A. Okay, so basically it looks kind of like this. So this is Andal, the bottom of Andal. This is Kartos. And the bottom part is a rectangle, and the top part is a right triangle. The angle of elevation is 4 degrees. And we know that Kartos is 92 meters high. And so that it means that this part that's 40 up to the height of Andal. And then, in addition, there's another segment here. We'll draw it in another color. This segment here is going to be 52. Okay, so that's like the remainder of the height of 92 after you subtract off the bottom part, which is 40. Okay, and so we drew a diagram. That's what we needed to do for this part. And then it says, what is the horizontal distance from A to C? So we need to find the bottom leg of this triangle. We got 4 degrees here. We know that this part is 52, and we want to know this part. So we're going to use tangent again because tangent relates the opposite with the adjacent. So we're going to write tangent of 4 degrees is equal to 52 divided by x. Then we're going to multiply both sides by x, and we'll get x tangent of 4 degrees. We're doing that to get the x out of the denominator. Now we're going to divide both sides by tangent of 4 degrees to isolate x. So we'll get tangent, or x equals 52 divided by tangent of 4 degrees. And tangent of 4 degrees is 0.0699. So let's do 52 divided by 0.0699, 744. X equals 744, and that is the distance between A and C, right? All right. Last part. The diagram below represents measurements relative to the centers of the base of the pyramid. The surveyors determined the angle at A to be 110 degrees and the distance from A to B to be 600 meters. What is the distance between B and C? Give your answer to the nearest meter. Okay, now we know more information than this because we found information, and I wrote here, you should use your results from the previous section. IB didn't write that, I did. Okay, so going back here, we're going to see that we know the distance between A and C on Dahl and Kartos is 744, so we definitely are going to use that. Okay? All right, so we want to know this length here. I'm going to call this length small a because it's across from big A. I'm going to call this small c, and I'm going to call this small b. If we go to the formula sheet, we can see, oh, by the way, when we look at this, we can kind of guess to see which law we should use. And you can see that this is not a right triangle, right? Since it's not a right triangle, you can't use SOHCAHTOA. They want us to find A. And we know C, and we know B, and we know angle A. So, can we use law of sines? We cannot use law of sines, and the reason why is because we don't know this opposite pair, right? We don't know this opposite pair, because we don't know the angle, right? And we don't know this opposite pair, although we do want to know small a. We have to know at least one opposite pair to use law of sines. So since we don't know any of them, we cannot use law of sines. So that leaves law of cosines. That's how you decide whether you're going to use law of sines or law of cosines. First, you check to see if you can use law of sines. If you can't, go directly to law of cosines. Now, law of cosines, there's two forms of law of cosines on the formula sheet. There's cosine A equals blah, 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 and there's A squared equals blah, blah, blah. Which one should we use? Well, in this case, we are looking for a side, which is small a. So we are going to use the small a version. What does the small a version look like? It looks like a squared equals b squared plus c squared minus 2bc cosine of big A. And as you can see, we know b, we know c, and we know cosine of big A, so we can obviously see that this is a perfect opportunity to use law of cosines. So I'm just going to fill in all the numbers, and then I'm going to show you how you can use the calculator properly to figure out the answer. Okay, so we're going to type into the calculator 744 squared plus 600 squared minus, a lot of people forget to put that minus there, they think it's plus. 744, 600, cosine 110. Okay. Wow, it's a huge number. Some people get scared by that. They think, oh my God, how can A be that long? Well, remember, this is not A, it's A squared. So how do you find A from A squared? You take the square root of it. So it's actually 1104. That sounds more reasonable, right? Okay. Then the last thing, or not the last thing. What is the size of the angle ACB? ACB is this angle here. Okay? Now that we know that small a is 1104, now look, we can use law of sines because we know this pair here, and we would like to know this pair here. So let's write that out. In this case, there's two forms of law of sines. There's law of sines that looks like this with the angles on top. There's also law of sines that looks like this with the angles on the bottom. Which one are we interested in using? Well, since we're looking for an angle, we're looking for this angle here, we want the angles to be on top. It's more convenient for algebra. So we're going to do that. So which pair are we looking for? We're looking for small c, big C, and small a, big A. So I'm going to rewrite this here so that C, sine C, C. Okay, so we're going to use this equation here. So first we're going to put sine of A, and sine of A is 110 degrees. We're going to put small a, which is 1104, and then we're going to put sine C, which we don't know, and then we're going to put small c, which is 600. Okay, and then we're just going to substitute in, instead of sine 110, we're going to write in the number sine 110, which turns out to be 0.940. So I'm going to put 0.940 over 1104 equals sine C divided by 600. Now I'm going to multiply both sides by 600, and then I will get an expression for sine C. So I'm going to do 0.940 divided by 1104, and I get something very small. And then I'm going to multiply by 600 because we want to multiply both sides by 600. And it gives me 0.511. So sine C is equal to 0.511. Now I'm going to take the inverse sine of both sides. I'm going to take the inverse sine of this left side. That will give me big C. I'm going to take the inverse sine of the right side. That will give me inverse sine of 0.511. What is the inverse sine of 0.511? It is 30.7 degrees. Okay? All right. Last one. What is the area of land inside the triangle ABC? Okay. This one, if you look in the formula sheet, there's a special formula you can use to figure out the area inside of a triangle that is not a right triangle. It's called 1/2 AB sine C. Okay? And in this case, let's look at our angles and our sides. Perfect. We know big C is 30.7 degrees, right? We know big C. We know little c, or we know little b, and we know little a. And those are the three things we need to use this formula. So we'll do sine of 30.7 degrees, which we already know is 0.511. And a and b are going to be 1104 and 744. 1104 and 744. Okay. Let's multiply it out. 0.5 times 1104 times 744 times 0.511. 209,862. Okay, 209,862. Okay, so that is the area of land inside the triangle. I think everything is meters here, so this would also be like meters squared if you want to put the units, but you don't have to. Okay, and that is it.